Hi General Math students, in this video we're going to discuss trust funds and perpetuities. In particular, the example that we're doing here is a trust fund. So this video is about trust funds rather than perpetuities. Just want to describe the idea behind a trust fund. Typically they're set up on behalf of somebody. So if you were to receive a trust fund, someone else has set the trust fund up for you by putting some money into an account. And typically the conditions might be that this person, often a relative, like a parent or a grandparent, will say, okay, when my son, daughter or whatever turns a certain age, like 18 or whatever, they will have access to this account or this trust fund, and that person will receive a regular payment from the account. So it's a bit like this. Let's say that this is the amount of money that is in the account. All right? The bank is going to add interest to that account each period and then pay some out to the person. And then in the next period, they'll add some interest on, and then they'll pay some of the trust fund out to the person. Then they add some on and pay some out. And they keep doing this until the trust fund is exhausted, until it's down to zero. So add a bit of interest, take a bit of interest out. A little bit like one step forward, two steps back, I suppose. And eventually the trust fund runs out and it's finished. So let's have a look at this example here where a trust fund has been set up by this person called Margot. Margot has written into her will that when she dies, $50,000 of the funds from her will be invested in a trust fund, and that will be donated to a promising young artist each year. Okay, so that'll last for 25 years. So over a period of 25 years, 25 lucky young artists will receive a bursary, some money to help them with their studies, I suppose. So for trust funds, we actually use the Annuities in Arrears formula. Now, we're familiar with this formula being used for, say, bank loans. The previous example involved a bank loan. So that's when someone borrows money and pays it back with interest to the bank. Right? Now, this is kind of the reverse. The money is held by the bank, but they pay it back to the person, but also with interest. So it's like the bank is borrowing money and paying it back to the person with interest, but the formula remains the same. So let's write down the different variables we need to know. So the total amount in the account P, in this case, is the $50,000. So that's how much is invested into this trust fund. They're actually asking us to calculate what this this regular payment will be, this bursary. So find the value of the bursary. They're saying, what's the regular payment? They're asking, what is the regular payment going to be? Okay, the interest rate, so this is an annual rate, so we'll convert that to a decimal. 6.4% divided by 100. So 0.064. Now, because it's an annual rate, it's not compounding monthly, quarterly, anything like that. It's compounding annually, so we can just leave that alone. And number of periods, well, this is an annual bursary or an annual trust fund payment for 25 years, so 25 periods. Right, so first thing, I'm going to show you the algebraic solution to this. We're needing to find the value of the regular payment here. So we need to rearrange this formula. Oops, don't want to scrub that out. I'll highlight that. We need to rearrange the formula so that the regular payment R is the subject of the equation. So that would look like this. R is equal to the total amount P multiplied by I. So we're going to take that interest rate, it's dividing on this side, so it multiplies on the other side. And then we divide by everything in the brackets there. They're multiplying by the regular payment. So everything inside those square brackets goes and divides on the other side. So it looks like a complicated formula to rearrange, but it's actually not that complex. Okay, now all I need to do is substitute these numbers, these values into this formula, and put it into the calculator. So you might want to pause the video, do this substitution, and see if you can get the same answer as what I'm about to get. I'll give you a moment to do that. Okay, I'm going to go ahead and try this one now. So I'll see if I can remember the numbers as we go. Okay, I'm going to use our fraction button here. And I'm going to go 50,000 multiplied by, get the fraction button going again. Oh, beg your pardon, I don't need that because it's an annual rate, so I'm not dividing. I can just go times 0.064. Oops, just lost in there. Give it another go. Okay, and then we divide that by. I'll just check. Oh, 1 minus. And that is to the power. Oops, there. Oh, I think that's okay. Calculator's just acting a bit funny here. I'll give it another go. -25. And we're getting $4,061 and $22. Sorry, that's not quite right, is it? This calculator's just not working for me, so I'm going to try it on this one. Just acting a bit funny. Let's try it again on here. 50,000 times 0.064. 1 minus 1 plus 0.064 to the power of negative 25. Oh, it was okay. Okay, so 4,061.22. Okay, so just want to point something out here. So we're getting 4,061.22. So that's interesting. I wonder how much interest was gained in this situation. If we think about this, if we look, we're going to get 25 payments of 4,061.22. Okay, so 406.22, and this is going to last for 25 years. So the bank ends up paying $101,530.50. So for a $50,000 investment, this trust fund, the bank in this trust fund, the bank actually has to pay slightly more than double that out. So that works quite well for these young artists. And Margot has invested her money quite wisely, if in terms of helping these young artists, because it does accrue quite a lot of interest. Okay, thanks for watching the video. Go ahead and check the description and try some of the questions for trust funds.